Ooh, hey everybody, this is Larry. This is March 3rd here in New York City. I am trying to do an extra random RNG problem that I haven't done before. And yeah, let's get to it. Today's extra problem is 1698. Oh man, the light's a little bit bright. 1698, number of distinct substrings in a string. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, I am on a 48-hour fast, a dry fast, so no water, no nothing. So I'll see what happens. But yeah, haven't seen this one or on Leetcode before. Oh, number of distinct substring is actually a very well studied problem. I don't remember it, to be honest. It's kind of funny and I feel a little bit sad. But one of my senior thesis when I was in college, in comp sci, and technically at that time it was computational biology, which is at the time a computer science subthing, and I don't know if it is anymore, but basically this comes into play with around DNAs, right, where you have 4 characters, and I was just exploring some combinatorial things about it with computational biology. Wasn't very good at it, to be honest. I think I was just not very good at proofs, which is why I never got that deep into academia. But yeah, but this is actually a problem that is very dear to me per se. But that was also a very long time ago. Or I don't know if this is a dear problem for me, but it is a problem that I have a history of, I suppose. But yeah, I don't remember how to solve this though, that said, because it just doesn't come up at all. I suppose not even on competitive, because I think this is the only problem that you can ask. But all right, let's brainstorm and let's see if I could remember this. So I mean, I do know some stuff about this, of course, but I don't remember the canonical way of doing it, so I would have to see. But the big idea is dynamic programming. Yeah. How do I look at this? I mean, the naive solution is going to be 2 to the n, and obviously, given 500 is too much. Apparently, there's an O of n. I thought that there's an n squared solution, but yeah. I mean, it is dynamic programming. I don't know. I mean, I kind of remember the solution, to be honest. Not gonna lie. But I'm trying to think like what was the proof about it? Because I just feel like it's muscle memory, but I don't want to go down that route. I want to like go slowly and do it from first principles. So I don't know. Yeah. Okay. So basically, all right, let me think. Right. I mean, I think one way that I could think about it is how many substrings of length 0s are there, right? I mean, obviously 1. I mean, it's not counting this answer, but you know that's your base case is 1, right? So maybe you have f of 0 is 0 to 1, and then f of 1 is I mean, it's just the number of distinct characters, but I'm trying to think what's a cleaner way of writing it, or in a way that we can build off this, right? Like maybe to be honest, I don't really remember it, but yeah, I mean, maybe another way of writing is that like 1 with the last character, maybe. I don't know if that is quite right, but maybe that's 1. And this is pseudocode, kind of. This is clearly not Python, but I'm just kind of it's stuff that I normally would write in my notebook, but obviously I'm illustrating it to you. But yeah, is that even the best way of writing it? I don't know, right? So f of 2, where the last character is a, so then a could end a b, but I don't think this is an easy way to kind of build out of it either, though, because because I forget about I remember the answer, forget the principle. Usually I'm better at the other way around, but I mean I think the more structural way is like 1 1, and then this is like 1 2. Then now let's say, oh, I guess this is not 2 2. It's still 1, because why is that? Okay, so I think the idea is that you want to count all the prefixes that isn't a duplicate, and it would be a duplicate if it matches the last time that this character has a thing with. Is that true? Like if you have an A, then yeah. All right, let me rewrite it in a different way. I'm trying to skip ahead maybe. So then now with with the first character is going to be A. If the first two characters is A and AA, building off the previous F0. And then next it's going to be with 3 characters. The B is going to be B, AB, AAB, right? And then the second B is just going to be B, BB, ABB, AABB, right? I'm missing some because I'm not adding. Well, I mean, I guess the ones I'm missing are the ones that are duplicated from here. So basically, you want to subtract the answer that you get here minus the last occurrence of here, because it is saying that all the previous occurrences, adding this as the last character adds nothing, right? Because it's already duplicated. So okay, so I think I get it now. That's kind of trick. I mean, I want to, yeah, I'll do it one more because then, but yeah, in theory, you know, yeah. And kind of, I'm not consistent with my notation. That's what I'm saying. But yeah, so then A, and then now all of these plus A, and all of these plus A, but then the only ones that don't dupe are, I think I'm also off by 1 or something, because you have to include the one where this one is the last A and then you add another one. So like you have A. Yeah, okay, maybe I'm gonna be off by 1, but we'll play around. Okay, fine, right? So then F is equal to 0 times N, say N plus 1. And then F of 0 is equal to 0, 1, and then for I in range of N, and then F of I, maybe last is equal to, right? So then here F of I plus 1 is going to be equal to just adding everything from the previous count minus the last time that we duplicate, right? So yeah, so this is going to be something like this. And then F of I plus 1, we want to subtract it from the last time that we've seen this. So if S sub I is in last, then going to be F sub S sub I, oops, last of this. Maybe it's off by 1, I think. Well, I don't know that yet because we don't do anything yet. But yeah, last of s of I is equal to I, and because this is I plus 1, I think this is I plus 1, right? And then we return f of n. Something like that? Or am I just like really weird? Guess we'll see very soon. Okay, so we're not, well, this is 0. Huh. Why is this 0? Well, let's print it out. Oh, no, I mean, alright. 1, right? And then another A. So A, this is going to be, oh, I have to do this plus 1 for adding a unique case. So maybe this is 0. Maybe that throws it off. Okay. That's not quite right. And this isn't right anyway. I think we want the sum of f. Because here we only add in, no, it's a little bit, I'm kind of in between. So basically this is saying this is the number of unique ones for ending here, which is not quite what we want. So this part is saying that this is ordered for no, no, this is just saying that we double count, right? But alright, so that means that this is 1. So this thing is going to be it adds 1 for but it also includes itself, so it doesn't need to, maybe this should be the index before that. Okay, maybe not. I mean, I think the idea is right, but I'm not counting right. Yeah, I thought I have premium. Do I not have premium? Why is it give me? Oh, oh. I mean, this isn't right anyway, but I just wanted to point out. All right, because this should be 2, is what I mean. So this, right? So this is 2 because it has all the counts before, but it's not double counting. Because here it removes the double counting. That's what we're trying to do here. But this doesn't double count. How do we get it to double count? Yeah, I don't think that's right. Huh. I mean, this would fix the first like 3, but that's not quite right, right? Because that's just case 2. I don't think the sum is right either, because we actually want this to be the answer in how we define it, because it is not the only uniqueness. Because if we count the uniqueness, then we have to sum over the uniqueness anyway, which is kind of awkward. Maybe, I don't know. Is this the number of unique strings? Yes, but then if we subtract it out, why is this wrong now? Why can't the sum of this be right? Huh. B is 2, which is wrong anyway. Because already it should be B. Well, this is wrong because this is wrong, I suppose. I mean, there is an n-square solution to fix this, but I don't want to do the n-square one yet, to be honest. That's why. And n is only 500, so we could do it. Because you can just loop over all the previous ones and then kind of concatenate and then just subtract out the duplicates. But that's not what I want to do yet. Maybe I'll have to, I don't know. Man, I'm struggling on this one, even though it's a medium. But it's just like it's a very specific medium, so It's not like a real medium, because if you haven't done it before, it definitely is hard. And if you've done it before, then you just do it very quickly. Unless you did it like 20 years ago or something. But this is wrong because this is wrong. How did I get this to be 2? Like logically. Why doesn't this work again? I just kind of didn't look, but so this is 2, this is 3, and then the second B is because it subtracts like this number or something. Am I wrong? No, I'm because it's still not double counting. That's why. Basically, this. Because this wants to give me the unique one, but it doesn't because I don't double count. How can I double count? I double count by looking. I think this is right though, for the double counting part, but because then now it is saying that we want to. I mean, maybe this is more awkward to do it this way. But basically, this is saying that this is equal to f sub I, which is the previous count. So then you have a prefix sum, and then this is the number of new things, and this is the thing that is subtracting the old thing, right? I think this is more right, but maybe not right enough, clearly. It's very wrong for this one, so maybe something's very off. Something definitely is very off. But there should be, for B, there's B, AB, and AAB, so there's only 3, but 3 plus 2 is 5, so that's actually right. 6, is that right? The only one that is new is AABB is what it's suggesting, but is that true? Let's see, right? I have to do this manually. Sorry, fam. Larry struggles. Right? And then for B, it can be B, A, B, A, A, B. And then for the second B, you have BB. No, already BB means that, and ABB, AABB already means that there's at least 3 new ones. Okay, so then what does this try to say? This is saying that there's 10. So there's 11 things, but 5 of them are dupes. Is that true? No, because only 3 of them are dupes. Oh, so then we have to subtract the unique part of this. Maybe I'm trying to do two things with one thing. Let's try. Right, so then now, how am I adding this, right? I mean, might as well just keep it this way. I don't know. Notation's a little bit weird. But yeah, but this is basically okay, right? And we want something like this because that's the first time that the last time it happened, kind of. I don't know if that's true. No, that's not right. Hang on. Well, that's very wrong. But is this 9 more right? I think. It should be. I mean, this is 8 clearly, right? Am I missing one? No, so 9 is not right. unique ones. There's only one unique. One unique is definitely not right because we can see that there are 3 uniques. So maybe this idea is just way off. Let me just leave it. How am I fixing this in linear time? It's just so off. Huh. We subtract this. But that is too much. What is this? This is basically includes all the ones that doesn't include because it includes all the one that doesn't include all the uniqueness, but it's a little bit weird. Huh. Yeah, I mean, I was trying to kind of like back finagle this, but clearly it's wrong. It's a progression. And out for some reason. Oh, maybe my browser's in now. I don't know. It's not. Okay, there we go. So this line is saying, all right, let's take all of these and then add 1, right? So that's how we get 11. But we do want to remove just this thing because that's the duplicate. Oh, do we? No, we don't want to. No, we do want to remove this count. But this count is not this count because this count includes all of the other ones. That's why I'm trying to kind of squeeze this back in, but it's not quite right. Because this count includes all the other the stuff that does not end with B. What am I missing? I mean, I tried the uniqueness part, but I don't know that that's quite right either. Okay, let's say. Right, so is equal to f sub I plus 1, right? Except for that we have to subtract it. Right, so u sub I plus 1 minus the last time, so something like that, right? And then here but it's not quite right. I mean, it gets this one right, but then the A is just falling apart. It grows too fast. And why is that? Okay, then maybe I could figure it out if I just go along. Right, so A, we immediately add 8 of these, which is, and then we subtract. What do we subtract? We subtract only these 2. Is that not right? So we have 8 plus 8 is 16 plus 1 is 17. Right? So this is 17 and then just minus 2. I mean, I don't know if this is 16 to be honest, but. And my mouse is just like. Hello, hello. Okay, just want to make sure. I don't know why my keyboard and mouse is not. It's either that or my browser, but all right. In any case, so we have 17 here. Number of unique is going to be, yeah, all these plus 1. But then the last A is going to be here, so then minus 2. Oh, this is maybe this is F. That's not right either. But that doesn't make sense because we want to minus the total count that's at. No, we want not. We don't want to because this should not be unique because that doesn't make it unique. But 4 doesn't make sense either. I don't know. But basically, the idea here is that we want to subtract this by the full thing that it is. Because we want to subtract not just this one, which is the uniqueness brought by the last A. We want to actually include all the things that ends with A. So the other 6 is okay, right? Because we can add A's to these. So we want 17 minus 3, which is 14, which is right, if we get it. But we're subtracting. I mean, I feel like it should be this. But it's not quite right. Because this is 7. Well, the full well, this is wrong. That's why. Because this should be kind of. Now I'm like running in circles. Why is this wrong? Oh, this is wrong because this B is not this B, my recurrences is really bad today, I think. This B, okay, so there's 5 of these. It takes all these B, add another one, but then wants to subtract out these 3's. I don't know that I know how to do it. It's just so specific. It's not a good problem because it's just like this is not a good problem because everyone can Google it, but it does come in other places though. I just like every time it comes up, I'm really bad at it, I think. But it's all variation on the same problem. I really should get this from first principles. I'm not I mean, I have the idea, right, I think, but I'm not expressing it quite precisely. Like, it's possible that I'm missing something. Okay, so let's see. What does this 6 represent to us? This is 5, that's good. Or for prefix sum. And then it means that we can create another new 6, which is true, but then now we subtract 5 uniques, which doesn't make sense. Which is why I had it in some like other funky way where I had this, but then now man, this is a disaster. reason why this is wrong is because what is happening? So you have 8 and we're happy so far. We have 8 things, and then now we want to add A. So then now we add A to all these, but then we want to subtract out this, but it's not the unique thing. Well, actually, this wouldn't even be the doesn't make sense that this is the unique part, right? It's the summation of all the things that have A's in the beginning. Right. Can I do something like this? Something like that, maybe? Is that, I mean, this is the same as before, I think, but represented a little bit differently. So I don't have to mess up with some of the indexes, but is this more precise? No. Why is this 11? Well, it's this 11 because this 6 is wrong. It is the number of things that ends with this character. So that's just going to be this plus 1. Right. 8. Number of things that ends with this character. So you have 8 things. And then now, number of things is 2 is technically right. So why is it not 15? No, because we have add 6 things. So why am I off by 1? Well, I'm off by 1 because we actually do want the AAA. So this is 15. 15 is right then, right? Maybe? And we could test if this is right because we can just do this. But yeah, so 15 is not right, it's 12. Why is this 12? Did I misunderstand this part? You add A to all these suffixes, it's going to be a new string, right? I am an idiot. I am solving the wrong problem. I'm doing subsequence and this is a substring. So it's possible that I had it right, it's just that I was... Yeah, I guess like I was like, I couldn't make sense of why this is wrong. I think like I wrote in a couple of different ways, but I think this is mostly right and I was just counting. But I didn't think to kind of check this because I don't know, I just didn't think about it. I guess this is why this is medium, because n squared is actually pretty straightforward. The only n squared number of substrings. I mean, it may be n cubed, but then you can do some like, you know, rolling hash or something, right? That's pretty straightforward. I am not a smart guy. I'm not a smart man. All right. Let me reset. Give me like a minute. Look, sometimes when you do things live, you're gonna misread things live. I was just trying to figure out like, why is this off? Or like, why is this off compared to here? I just assumed that 21 is right and I was wrong, but maybe this was the right one. It's just that I was kind of confused. I was like, that doesn't make sense. Like I was off by 1 at some points, but yeah, okay, fine. All right, let's think about this again. So the n square stuff is pretty straightforward. You start with I, like you have something like right. So like, and this is start, and then you can do a rolling hash or something like this, but just like yeah, for I don't know, j in range of start n, and then you kind of just like build on it incrementally, build incremental hash, and then just return the count. So that's n square. Is then O of n one? Man, can't believe I misread this so long. All right, let's think about O of n1. How do I do this in O of n? How do I do this in O of n? How do I do this in O of n? Alright, so let's just say we have A. What does an A, the second A mean to us? We're gonna type it out. Man, I just couldn't make sense of it. I am not a smart boy. Definitely not today. But yeah, okay, so let's say we have A, and then we have AA, and this is just like from the beginning, right? So now we have 7. Let's say we remove this. Then what does that mean? Now we have all this, and basically it's going to be just A, B, A, B, B, A, A, B, B, A, B, A, B, B, A, B, A, right? And the one that we can remove is going to be this one, right? Man, if this is some suffix tree thing or suffix array thing, like a linear construction of suffix array, I'll be way, I don't know, just be like, what the hell? And then B, I'm thinking about just like doing, like looking at this and then just kind of, that's the thing, right? Is that I do have I feel like there is a suffix array answer and maybe even a CZZ function answer. But is that even true though? Because can you keep on going? I don't know that I know how to do this in O of n, and unless it's like some crazy algo. I might just cheat and look it up, to be honest. I have a suspicion that is a crazy algo, but I could be wrong. Because well, I mean, and by crazy algo, I do mean like suffix array is a crazy algo. Maybe I don't need to keep on writing this, but because I think like the thing you want to exploit, like this is about the feelings about the problem. I don't know if it's like this particular one, is that like, you look at the original string, oops, I guess that's why things look funny, and then you kind of just compare it to itself, right? Kind of like, and then there's only one prefix, and if there's only one prefix character, then that means that everything from the suffix of this is going to be new, right? And then now you kind of look, okay, now it's 2, right? This is 0, so everything is new. This is also 0, so everything is new. That's not true, actually, right? That's not true. I mean, it's true here, but for this one, you actually also compare it with like something like this. Then it has some overlap, but not overlap with this, right? So I don't know that I know how to do this one in linear time. Like I have a feeling it is some heavy machinery. So we'll do the n square way. So we'll see, right? So then now you have a hash is equal to 0, right? So you have lookup is or lookup is equal to set, and then this is just like like Robin Crop, rolling hash basically, right? And yeah, and this is basically right? So this is equal to s sub j minus character of a. I like it to add 1. Some base, and then mod and mod. For now, I'm just going to write something lazy, and because there's no challenges in this one, right? Just some big enough number, right? And then lookup dot add h, right? And then we just return length of lookup, right? Pretty straightforward rolling hash. If I'm able to get it right. What the? Oh, whoops. Yeah, let's give it a submit, but alright, maybe there's a hash collusion. That's fine. Yeah, just actually, come on, how many hash solutions are you gonna get? Alright, let me find another mod. Big prime, maybe they alright, hang on, sorry. I guess that's a very common mod, I don't know. Alright, look, that's the problem with rolling hash sometimes, but yeah. Alright, let me see if there's a linear solution. It is suffix array, alright. Yeah, I mean, suffix array is n log n. I think there's a suffix array that's O of n, maybe, but I could be wrong on that one. Well, the way that they did suffix array is lazy, but I guess there's a linear time suffix array solution. Okay. Okay, yeah. I mean, I was thinking about doing LCP from suffix array, which is what I was going to say. But yeah, and there, of course, suffix array there is a linear solution, but as I say, that is like a ridiculous one. It's like I don't know how to say it. Whatever function, maybe is Wikipedia. Yeah, still linear. Oh yeah, Arconin algorithm. But oh. But yeah, that is a ridiculous solution. There's no way I could implement this during the contest. I mean, I guess like an n log n or n log n I can actually do, but still, like I said, is ridiculous. I've done this before actually, but it is such a high level concept that I refuse. Though, you know, using a lazy mod and apparently was the wrong thing too, but that's it happens. That's why you do double hash sometimes. But yeah, that's all I have for this one. Let me know what you think. I misread this problem for so long, but yeah, hope you enjoyed it. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.